Hi everybody, I hope you've all been having a good term and that your exams went well over the last couple of weeks. This is the moment I'm sure you've all been waiting for throughout the time, the moment where I announce the winners of the best videos that you produced as part of your Macromolecules independent assignment back over the Easter break. Now, there were more than 140 videos submitted, and I was really blown away by the amazing efforts that you all put in. That's way more videos than we'd get in a normal year, so thank you for all of your hard work and your efforts. There were some really tremendous videos, and it was a really difficult job for me to pick which ones I thought should be awarded the prizes. Now, I'll start off with a few commendations for particularly good efforts. These are videos that haven't won prizes but came pretty close, and the first of those I wanted to highlight was the video by Maria Kuznetsova. Sorry for my pronunciation of your name, and that's for having the video that undoubtedly had the catchiest title out of all of those that was submitted. So Maria's video, "Can Watermelons Survive Falling from a Tower?" got me hooked instantaneously, and I was intrigued by what was.
It forms a uniform layer around this watermelon, and it lands safely and undamaged.
If you got to watch the rest of Maria's video, you'd have also seen the example where the watermelon wasn't coated in polymer and unsurprisingly went everywhere. The second commendation goes to Adam Williams for his video on polymers in COVID. I thought this was a really fantastically made video, really nicely edited and cut, and well done to Adam for a really fantastic effort.
Reaction test has been utilised throughout the pandemic. This technique, developed in 1983 by biochemist Carey Mullis, allows for rapid replication of copies of a specific DNA sample, so it is amplified enough to be studied in detail.
And then finally, my third commendation goes to Amy McDermott. I really liked the way that she presented her video. You'll see it in a second. It was a really nice style that allowed her to make a really attractive and engaging video, so well done, Amy.
They are small side chains which extend off the main backbone of the polymer. These methyl groups are located on every other carbon atom.
And so now the moment you've been waiting for, the prizes, and we'll start off with the prize that was voted for by you, the student body. And overwhelmingly, your favourite video was the one that was made by Oliver Smith on polymers in running. Well done, Oliver. You gave a really nice example of being able to talk to a camera while staying engaging and also getting across information really nicely. Well done.
And the laces, and also the supportive structures here along the sides, but we're going to focus on the sole and the laces. So, what's so special about this running trainer?
Now for the prizes awarded by me, and third prize goes to Parissa Munir for her video on polymers in cancer therapeutics. I thought this was a fantastic video. It was really engaging with the way that you spoke at the camera, the presentation that you had, but also the scientific content was delivered in a really interesting and engaging way. So well done to Parissa.
A polymer that can display a love and hate of water at the same time is what we would call amphiphilic. This property means that in the aqueous environment of blood plasma, the polymer spontaneously arranges itself as shown in the diagram here.
Second prize goes to Casper Critchlow for a video that, I'll be honest, when I first started watching, I thought was fairly standard. Good scientific content, but not super engaging. But then this happened, and it really hooked me, and I really enjoyed the way you used a bit of entertainment to make your video engaging.
To understand when a polymer can be recycled, we first need to understand solid polymers' ability to exist in two different forms. Take this non-specific hand gel. No, seriously, you can take it. We're COVID secure.
And then finally, first prize goes to Miles Ralston for his video on polymers in football. There were a load of really excellent aspects to this video. Firstly, the scientific content was right on point. It was engaging. You did some really nice editing with lots of videos coming in. You did some examples and some demonstrations of polymer chemistry as well. So well done to Miles on a really fantastic video.
Which is then able to react with monomers. Propagation, where the chain grows, and termination, where the chain stops growing. Leather, and especially cotton, are very absorbent, meaning that if it rained or the grass was wet, the game was slowed quite considerably. The easiest problem to solve was the cotton, which was replaced by thinner, more flexible, and more breathable. Low enough temperature, it is hard and rigid. This is called the glassy state, and there is not enough energy for chains to move past one another. As we raise the temperature, we reach a point known as the glass transition temperature, where there is enough energy for the individual chains to move within the solid, making it soft and flexible. This is known as the rubbery state.
So well done to not only all of our prize winners, but also all of the rest of you who made videos this year. It was a really fantastic effort by all of you under really difficult circumstances, and I really enjoyed watching all of your independent investigations as well as those written articles that people made as well. So that's all from me. Good luck for the rest of the term, and hopefully we'll see you all soon.